Hey, what's up, guys? Mr. Garcia here, back again with another video. This is your review video for your post-test upper bound. It's been a great summer. So right now, the topics we're going to cover in this video are vertex form or quadratic equation, multiplying binomials, focus and directrix, both with a vertical parabola and horizontal, and then just factoring all together. Now, with this video, my goal is not to teach every single topic, but just kind of like a little refresher of like, hey, remember when we did this? Well, here's a little refresher. Here's like one example. There are multiple videos up on my channel about these. So if you have any more questions, though, you can definitely send me a message and we can work from there. So as a reminder of quadratics, we covered some terms, some vocab, as in the vertex is our highest or lowest point, and that's also called your max or your min. The axis of symmetry, and remember, mathematicians are very efficient or just lazy. It's also called the AOS. That is a vertical line drawn through the vertex of a parabola around which the parabola is symmetric. Basically, there's symmetry. And we talked about x-intercepts, roots, solutions, and zeros being the solution to a quadratic equation. And biggest thing here when we discuss vertex form was we're saying, hey, in that form, y equals a parentheses x minus h squared plus k. Our vertex is that h comma k. So that x value in the parentheses is the opposite h. The y value is just k. Um, a value, we did discuss transformations. I'm not requiring you to memorize those different 6 different transformations that happen. But when your a value is negative, that does mean it's a reflection across the y. Again, normally your parabola kind of opens up like this. If you have a negative a value, it'll just open up like that. So some practical examples that we worked on in class, but now let's see if you remember. And also with this video, it's a great way for you to test yourself. So I'm about to work through this example. Pause the video, try it by yourself to see if you remember everything, and then you can just test yourself. So it's a great way to prepare yourself for the post-test. But we're just going to state the characteristics of these quadratics. Notice they're in vertex form. So, and I'll put vertex form up here in case you need it. X minus h squared plus k, and then vertex h comma k. Perfect. So the vertex here again, remember, is the opposite h comma k. So on this first equation, y equals negative 1/2 parentheses x minus 4 squared plus 3. My vertex again is at opposite h, so it'll be 4 comma my k value. It'll be 4 comma 3. And that axis of symmetry, it's just that vertical line that goes through the middle of the vertex. So it's where your parabola is symmetric. That means it's going to go through the x value of my vertex. Biggest thing here, remember, you must say x equals. Your axis of symmetry is a line. That's the definition of axis. It's a line. So you must say x equals 4. If you say 4, that's going to be fortunate when you get it wrong. Does it open up or down? We're like, okay, wait, what controls that again? The a value. The a value is the value out front of my parentheses, so negative 1/2. Since my a value is negative, that means it's going to open down. Domain, given quadratics and not in a real world situation, we always have a domain of all real numbers. That's always the case unless it's a real world situation, but that's a different discussion. Okay, range. I always love leaving range to the very end because I'm going to use the information that I found to help me out here. So I got this vertex of like 4 comma 3 right here. Okay, and I know my parabola is going to open down. And I know that the range is all my possible y values. So to figure out what my range will end up being, I gotta think, what is my minimum or what's my lowest y value and what's my biggest y value or my maximum. So with this parabola, notice it's going to open down forever. So if I had drew this on like a coordinate plane, something like this, it's going to open down. And so that vertex is my maximum point. I can't go above that vertex. So I do know that the biggest value I have for my y's is 3. I can't go above that vertex. Now the question is, how far below do I go? Do I go only down to -2? Only down to -7? How far do I go? Well, let me get my laser pointer. Our arrows here at the end say they go on to infinity. So that means here my range is going to end up being y is less than or equal to 3. Now that is where just inequality notation, you could, if you want to, do this in interval notation. So I'm not requiring it. If you were doing interval notation, it would be parentheses negative infinity 3. Notice the brackets mean equal. The parentheses means does not equal. So with number 2, let me move my person all the way. Whoop. What's up? So same thing, find a vertex and then just go from there. So vertex is opposite h comma k. So on the inside of my parentheses, it's x plus 7. Therefore, my vertex is going to be -7. And then it's comma k, so that k value is attached on to the very end. So that'll be comma -2. Awesome. Axis of symmetry. Axis of symmetry. It is the vertical line that goes through my vertex, which in this case is going to be x equals -7. Does it open up or down? Remember, look at your a value. If your a value is positive, it's going to open up. If the a value is negative, it's going to open down. In this case, our a value is positive. That means it opens up. Again, quadratic, not in a real world situation. Therefore, domain is always all real numbers. We did a little fancy R there. And our range, I always recommend drawing out a little parabola just so you can get it in your head how it looks like. It's going to look something like this. No, is it perfect? Not really, but I get a good picture. So my vertex here is -7, -2. And with this here, again, ask yourself, what's your biggest vertex? What's your biggest y value? And what's your smallest y value? So with this here in this case, my smallest y value of my vertex is going to be -2. I won't go below -2. Now ask yourself, okay, if my smallest is -2, what's the biggest number I can reach? There are arrows at the end of our parabola. That means I'm going to go to infinity. So my range is y. It's greater than or equal to -2. Again, if you want to write an interval notation, I would do -2 and infinity, although you don't have to do interval notation. Oh, my bad. Yeah, that was it for that one. Okay, distributed property. Make sure you know how to multiply using distributed property. Yes, you learn an acronym called FOIL, first outside, inside last. But FOIL, again, is just the distributed property. FOIL falls apart when you have 3 terms in the middle, or when you're multiplying 3 terms times 3 terms. Distributed property is essentially just FOIL, or FOIL is just essentially just distributed property. So for this case, on the left side, I'll do FOIL just for y'all, and on the right side, I'll do the box method that we also learned. Okay, so on this first one here, and I'll do different colors because I have that ability. My first 2 terms, excuse me, is going to be x times x. My outside 2 terms is x times -2. Inside 2 terms is 4 times x. And my last 2 terms are going to be 4 times -2. Again, that's just the distributed property. I took my x and multiplied it by everything in the second binomial. I took my +4 and multiplied it by everything in the second binomial. I'm distributing it. I'm not going to do the multiple colors for this part because that'll be a lot. But first times first, so x times x would just be x squared. Outside, so x times -2, which is -2x. Inside, which is 4 times x, which is 4x. And then finally, 4 times -2, that's my last term. And then combine like terms. So notice we can combine these middle two terms. And I'll end up with an x squared plus a 2x minus an 8. X plus 4 times x minus 2. Again, same question, but just with a different method now. Okay, so we learned a thing called the box method. Does it really matter how I orient all these stuff? Doesn't really. I could put the x plus 4 on the side if I want to, and the x minus 2 on top. Usually got to pick one. So same thing here. You may have learned this as Punnett squares in biology. I know you did. Probably just forgot. Each term or each box is going to represent two terms being multiplied. So in this box, I'll do x times x. In this one, I'll do 4 times x. Here, x times -2. And the last one, 4 times -2. The box method is just the distributive property, but nice and organized. 4 times x is just 4x. X times -2 is -2x, and 4 times -2 is -8. It's great, especially if you need to stay nice and organized and you can't read your work while doing distributive property, especially when you get like a lot of terms and you don't want to mess up. Maybe you forget to multiply a term or forget to do something. It's just nice. It really is. Notice again, this becomes the exact same as the left side, so I'm not really talking through it too much. And thankfully, we get the same trinomial as our other one, because that would be really embarrassing if it was different. Distributive property, make sure you know how to multiply two binomials. So from there, our first big topic we tackled was focus and directrix. And so I think it was Davy Crockett I brought in. Yeah, how he showed you with the patty paper how that actually worked. The geometric definition of parabola. It's the set of all points in the plane that are equidistant from a given point, and that's called the focus, and a given line called the directrix. Okay? So the parabola is always going to open in the direction of the focus and away from our directrix. Always open in the direction of the focus and away from the directrix. And so we discussed two different types of parabolas. We've known about vertical parabolas, but then we're like, oh, there's a thing called a horizontal parabola, which is new, which is different, but it's totally fine. If our directrix is a horizontal line, our parabola is going to open up or down, depending on the focus. If our directrix is a vertical line, parabola is going to open left or right or left, depending on the focus. Again, we discovered two different types of parabolas, vertical and horizontal. Through the proof of the distant formula, we discovered that A in front is going to be equal to 1 over 4p. And I didn't write this down. I apologize. So I'll write it right now. P is the distance from the vertex to input focus or directrix, all depending on what you want to do. But we know the vertical parabola because we know that vertex form. And then with this horizontal parabola, remember, everything's just switched. The process is the exact same. Everything is about it exact same. It's just flipped. So we got x equals a parentheses y minus k squared plus h. Again, notice your x and y are flipped and your h and k are flipped. They still serve the same purpose. They're just in a different position. And so we did some different examples. Again, there's more videos on my channel of me going through these things. But quick refresher, if I give you a parabola with the focus of -7, 2, and a directrix of y equals 10, let's write the equation. I always recommend plotting a picture. Even if it's a little kind of vague sketch, it works out perfectly. But we'll use a fancy picture. I got this from Delta Math, as you can tell. So with this here, I always recommend plotting a picture. Now, we want to find plus k. I'm going to probably should have wrote these beforehand, but you learn as you go. Perfect. I want to find a parabola. And I knew it was our vertical parabola. I knew it was going to open up or down just because I looked at the vertex, I looked at the directrix and the focus. Notice our directrix was a horizontal line. And so that is going to mean k is going to open up or down. So let's find our vertex first. Our vertex will help us find our value of p, which will help us find our formula altogether. So with this here, remember, the vertex is right in between the directrix and focus. So this total distance from our directrix to focus is 8 units, okay? And so if the vertex is right in between the directrix and focus, that means it needs to be 4 units away from the focus and 4 units away from the directrix. And from here, I will either count up or count down from the directrix. Doesn't matter as long as I'm in between the two. So that takes care of the y value part, up or down. What about the left and right? Where is it at left and right wise? Well, remember, a parabola has symmetry. And that symmetry, that axis symmetry, is going to go through the vertex and the focus. So our focus and vertex will carry the same x value. So in this case, we have an x value of -7. And let's find that y value. So if it's 4 away from the focus, I'm just going to count up 4. Or I could have counted down 4 from the directrix. Doesn't matter. So we got a vertex here of -7, 6. Awesome. Now ask yourself, okay, is this parabola going to open up or down? In this case, this parabola is going to open down. How did I know that? A couple things. One, it's going to open away from my directrix. And so since my directrix is up here, it's going to open down here. 2, our focus will always be in the middle of our parabola. I always made that statement of the parabola wants to hug the focus. That is true in this, that's true always actually. The parabola wants to hug the focus. The focus is going to be on the inside of my parabola. So why is that important? Well, when finding my a value, I know that it's going to end up being negative. My a value needs to be negative because it needs to open down. And again, p is the distance from our vertex to focus or vertex to directrix, which is 4. We saw that already. So I'll go ahead and say -4. Again, it needs to be negative because our a value needs to have a reflection across the x-axis. So we got all this stuff, we got all this information. Let's actually put it together and get our vertex form. Perfect. So we saw our a value was 1/4p, and we had here that was going to be -1/16. And we know our vertex is h comma k, so it's always x minus the h value, and then plus our k value. So it's going to be x minus my h value plus my k value. Now, we like to clean things up, make sure they all look good. So x minus -7 is the same thing as x plus 7. Perfect. Now, that was for vertical. For horizontal. Again, plot a picture, so I just got that from Delta Math. Nothing too crazy there. We got a focus of 11, -8, and a directrix of x equals 3. Now, I know this would be a horizontal because my directrix is a vertical line. So, if you forgot, standard form is going to be this, 1 over 4p, and then vertex, perfect, h comma k, amazing. So, I already plotted it. Well, Delta Math plotted it for me. From here, again, let's find the vertex. That's my priority. My priority is finding the vertex. Vertex, right in between the focus and directrix. The vertex is right in between the focus and directrix. So this total distance right here between the directrix and focus is going to be the difference in the x values, which is a value of 8, which was not on purpose, same as last time. Therefore, if our vertex is in between them, it must be 4 away from the directrix and 4 away from the focus. Again, I didn't plan that. Or I can say I did plan it to make me seem more intelligent. Okay, our vertex. Last time it had the same x value as our focus. And that was only because it was a vertical parabola. In this case, it's going to have the same y value as our focus. You may be asking yourself why. Well, because it needs to have the same axis of symmetry. Again, there's that vertical line, or I guess a line, that goes through our parabola. And if it goes through our parabola, it's going to go through the vertex and the focus. And so our vertex is going to have a y value of -8. To find our x value, well, count 4 units away from the directrix or 4 units away from the focus. In this case, or actually in all cases, it doesn't really matter. It's going to have an x value of +7. So that was nice and handy and all that stuff, but how do we know which way it opens? Again, it opens away from my directrix and opens in the direction of the focus. My parabola wants to hug my focus. Now, that's great and all. However, how does that affect my A value? Well, with our vertical parabolas, if it opened up, that meant my A was positive, and if it opened down, that meant my A was negative. Very similar for the horizontal. If it opens to the right, or I guess to the right, our parabola is going to be a positive A value. And if it opens to the left, it's going to have a negative A value. In this case, we open to the right, so our A value is positive. So my value of P is not going to change signs. That's great and all, but we have all this information. Let's actually put it to use and get our equation. Plus h, perfect. So x equals our a value, which we saw was 1 over 16. And we're going y minus the k value. And our k value in this case is going to be -8 plus our h value. But again, we want to clean this up and make it look pretty. Y minus -8 is the same thing as y plus 8. And then you rejoice because you made your equation. So that was focus and directrix. And from there, I was like, well, biggest thing that people tend to struggle with in Algebra 2 in the first semester mainly is quadratics with factoring. Factoring. And we reviewed these 4 different terms. That, hey, expressions have roots, so equations have solutions. Notice there that it's an equation because there's an equal sign. Functions have zeros, so it's f of x is a function of x. And graphs, did I put the graph there? Okay, I did, perfect. The graphs have x-intercepts. So that was just some terminology I made sure you needed to know. And a equals 1 for factoring. When our a value is 1, so again, It's highlighter. It's that value right there. When you have no coefficient in front of the x squared, that means you have a coefficient of 1. And so when that happens, life is good, life is great. You're rejoicing at that point. The expression must be in standard form. If it's not in standard form, make it a standard form. And the factor, we want to find the following. We want to find two values such that when you multiply, let me make sure this is back. When you multiply, the product is C. And that when you add, when you add them, the sum is your B. Okay, so an example we'll work out together is x squared minus 4x minus 32. So with this one here, notice in the standard form, ax squared plus bx plus c, our a value in this trinomial is 1. That's good. That's great. I love it. And if it helps you, I tend to tell my students to write out what their a, b, and c is so they are aware of what their goals are. So let's find the factors of 32. Two numbers that multiply to be 32. Don't be afraid to use a calculator. No shame in that whatsoever. I know 3 doesn't go in, 4 does. I'm running out. I did that really crooked for some reason. That's weird. And that'll be it. 6 doesn't go into 32. I just did it in my head, but you can check with the calculator. 3 doesn't, 5 doesn't, and 7 does not. So we have 3 pairs here, nothing too crazy. And with these 3 pairs, we need to find one pair, perfect, that when you multiply them, you get your C value, which is negative 32. And then when you add them, you get your B value, which is negative 4 in this case. So you may need to do a little bit of guess and check. Try to see which one adds up to be negative 4. So 32 minus 1 is 31. 32 plus 1 is 33. That's not it. Okay, so 2 plus 16 is 18, and 2 minus 16 is negative 14. That's not it. 4 plus 8 is 12. That's not it. 4 minus 8 is negative 4. Okay, so 4 minus 8, that means my 4 is positive and my 8 is negative. But does that equal the top condition as well? 4 times negative 8 is negative 32. Awesome. So 4 times negative 8 is negative 32. That's great and all. How does that help us? Well, we can change this trinomial and we can now rewrite it to say x plus 4 and x minus 8. And I'm going to claim that that's the factor form, that those two expressions are equal. Now, you may be asking yourself, how do I know you're right? How do I know you're a liar? And I will tell you the reason why is because I have a math degree. No, that's not the reason why. Because I can prove it. I'm changing colors for some reason a lot. I can prove it by multiplying the two. So the distributive property is going to tell me that if I multiply these two binomials together, I better get x squared minus 4x minus 32. If I don't, that means I messed up. I need to go back, look at my work, and change something. So let's multiply. Distributive property, we love it. We love everything about it. So x times x is x squared. X times negative 8 is negative 8x. 4 times x is 4x. And 4 times negative 8 is negative 32. Now with this here, we're like combine like terms. We can combine our middle two terms, which is going to give us x squared minus 4x minus 32. And bam, look at that. That is the same thing as what we started with, which means that x plus 4 times x minus 8 is our factored form. Now, we didn't discuss how to solve quadratics, so that won't be on there. You just need to know how to actually factor quadratics. We learned 3 different methods for factoring where an a is greater than 1. And on my channel, again, there are 3 different videos, one over grouping, one over borrow from brother, and one over box method. Now, grouping and box method will come in handy second semester of Algebra 1. of Algebra 2. You're on Algebra 2. Borrow from Brother is great right now. It's going to kind of fall apart in second semester. So that's up to you. I'm going to go ahead and do box method just because that seems to be the biggest thing you guys like. If you like grouping, please do grouping. If you like borrow from Brother, please do borrow from Brother. If you like the Texas T or the cross method or the star method or diamond method, there's so many different methods out there. You can use that as well. Just use the method you're most comfortable with. That's all I ask. Again, in our standard form, ax squared plus bx plus c. If you notice something, you notice your a value up here. What? That's not a highlighter. You notice your a value is 3, which is okay, but that means we need to use one of the 3 methods. Man, this is a mess right now, isn't it? Perfect. The beauty of it is I'm not going to edit any of this out. Awesome. So my A, B, and C value. My A value here is just 3. B is negative 17, and C is 10. So if you choose grouping or box method, this first part is going to be very similar. Very similar. You always need to multiply your A times your C. Again, we want to take account for all the different possibilities we have with our binomials. So we multiply our A times our C, which in this case is just 3 times 10, which is just 30. Next, find the factors of 30. So 2 numbers, when you multiply, you get 30. And nothing too crazy with these numbers. And in fact, we are done. Perfect. I have 4 pairs now. Again, not too bad. Could be worse. So we're still on our grouping and box method is still doing the same thing. I need to find 2 numbers. Then when you add them, you get your B value, which is negative 17. And 2 numbers, when you multiply, you get your A times your C, which is 30 in this case. So last time when our A value was 1, I wanted just my C term because it was still technically A times C, but it was 1 times your C. But in this case, it is still your A times your C, which it is 30. So that being said, we need to look at those 4 pairs and see which one works best for us. Okay, in your head, out loud, doesn't matter. Add them up together and see. So add them and subtract them. 1 minus 30 is negative 29. 1 plus 30 is 31. That's not going to work. 2 plus 15 is 17. But we need negative 17. That might work. Let me check the rest of them though, okay? 3 plus 10 is 13. 3 minus 10 is negative 7. That won't work. And 5 plus 6 is 11. And 5 minus 6, negative 1. Okay, so 2 and 15 has to work. And if we notice again, I said 2 plus 15 was 17. But I need negative 17. So this is where you pause the video. You're like, well, Mr. Garcia, clearly you must do. Awesome, you're correct. Clearly both of the signs must be negative. And that's great because a negative times a negative gets us a positive. And so negative 2, negative 15 works for us. That's great and all. What do we do next? This is where grouping and box method differ. Actually, box method is just grouping, but just organized. 17, I'm going to split that up as 2 terms. So instead of saying negative 17x, I'm going to say negative 2x and not negative 15x. Why is that so important? Well, if you didn't know, box method is all about a box. Surprise, right? Box method is all about box. We're going to place all of our terms inside the box and then just factor them out. So my first term was 3x squared. Last term was 10. Wait, we have a negative 17. Oh, wait, we just said that negative 17x is the same thing as negative 2x minus 15. So let's put that in the box. Negative 2x minus 15x. That is awesome. That is great. Now, we need to take the greatest common factor of my first column and second column, and then the greatest common factor of my first row and second row. Doesn't matter where you start, you just got to start. So we'll start with our first row. The greatest common factor between 3x squared and negative 2x. I need to see what numbers they have in common, or where numbers goes into both the coefficients, and if I can take out any variables. So my coefficients on that first row is negative 2 and 3. Okay, is there a number that goes into both 2 and 3? Only 1. So I'm going to factor out a 1. I'm not going to write it because it's just 1. Do they both have an x in common? Oh, they do have an x in common. I can actually take out an x, which is good. Okay, next part right here. 3x squared, my bad, negative 15x and positive 10. So ask yourself, what number goes to both 15 and 10? 1 goes into there. 2 doesn't. Ooh, 5 goes in both 10 and 15. And is that the biggest number? It is. So 5 goes in both 15 and 10. Now, notice what I'm about to do here. That 15 is negative. So while yes, you can take out a 5, I'm going to go ahead and take out a negative 5. Okay? Can we take out any x's? Nah, we can't, which is fine. Totally fine, you know. Okay, now go to the first column, 3x squared minus 15x. Can I take out any coefficients? Well, between 3 and negative 15, I can take out 1. I can take out 3. 3 goes to the 15. So I'll take out 3. Can I take out any x's here? I can. I can take out 1x. And then, same color, why not? So between negative 2 and positive 10, oh, that's not good. Negative 2 and positive 10. What number goes into both negative 2 and 10? 2. And so, again, even though you can take out a 2, I'm going to go ahead and take out a negative 2. 3x minus 2 and x minus 5. So what I'm doing from there is I'll rewrite this as 2 binomials, x minus 5. And that's getting really close to that work over there on the side. It's totally fine though. Whoa, make it work. Perfect. Amazing, isn't it? If I wanted to test myself, if I'm like, did I do that box method correct? Oh my goodness. You can still multiply those 2 binomials together. And so if you're uncertain, I will check real quick. I won't walk through the whole process out loud. I'll just do it really quickly. As you can see, I still get the same trinomial I started with. So box method, grouping, bar from brother, doesn't matter. Now, as you saw, that was the last slide. This is a great review for your post test. I'll just say that. If you have any questions, have any concerns, one, I do have more videos on this channel. Just go to the playlist button and click Algebra 2 just so you can filter it for you guys. And then from there, if you need more help or if you want more practice, I can assign Delta Math for you just for extra practice, or just ask me and I can make a special video just for you. But if you don't have any other questions, I'm excited for class on Tuesday, and I will see y'all later.